Testing. Okay, everybody. Hopefully we are back. Sorry about that. Welcome on into the Dragon's Den, everybody. My name is Digital Dragon, and I'm a 3D printing streamer here on Twitch. Hey, Petty Ruxpin, welcome in. You walked into an ad. I'm sorry. When is the Raleigh meetup? The Raleigh meetup. Let me. There we go. Good enough. Sorry about that. The Raleigh meetup is the weekend. 1 second, and I'll tell you. 26th. The Raleigh meetup. The first Raleigh meetup is going to be April 26th. It's going to go from noon to 3, which means the stream on the 26th will most likely be pushed off later in the day once I'm done down there at the Raleigh meetup. They say I'm able to stream down there, but I have yet to take anything out of here to try and get it set up because it'd have to be a complete different setup. Like I would have to take things down off of this machine, get all my scenes and everything set up on the laptop so I can, it would be a lot of work to get the stream set up. I would much rather have some type of capability in place there that just stays there. But I don't know. We'll see. I'll look to see what I can possibly do for a stream setup from there. Hey, Chewy, welcome in. Yeah, failed to launch. Yep, it was. You're hoping to win something in the poly. Me too. I was riveted to the Polypalooza, just waiting. Hope fingers crossed, toes crossed, hoping I would win something. And alas, I won nothing. Yeah, and I was hoping to win something because here, let me pull some things up real fast. Yeah, that's good. And I'll show you what I'm personally thinking about in the background. That one. And that one. Hey, Mr. Wizix, welcome on in. Yep, refresh time. Hey, Timor. Glad you guys are doing good. Hey, Glendon, how are you doing? How many points? I had like 993. So I was pretty close to the 1,000 mark. Merch, by the way, Bang merch. And you can take a look at all of the merch, like our cups. Once again, we have light mode cups in 12, 15, 20 ounce. That was a 20 ounce I was just drinking out of. We have dark mode cups in 12 and 15 ounce. I would have one to show, but I busted the handle on it, so I need to order a new one. And then we've got light and dark mode water bottles. And we also have some of the mugs with the old logo, which is just Digital Dragon. That's me versus the new business name. Thank you, Chewy. Brain's kind of fried here. A lot going on. A lot came in the mail yesterday. I got a lot of things in the mail for the Optimus P1 that's over at Ecovate. We got a couple of the plastic extruders. Now, how can I say this? I did borrow the right-hand extruder off of the KDX Pro because it is, well, it's the same exact thing as the one on the Optimus. The only difference is, and I'll go bench side maybe. Yeah, there we go. On this arm, this one is straight on the Optimus, and on the Kitty, it just kind of dips down on the arm lever. The only difference between the two. So I borrowed the one off the Kitty that I was rebuilding for my DM on Friday nights, and took that down there to get that printer working. And apparently last night they sent me pictures of a Benchy. It had a layer shift, but it does prove that we're pushing plastic. Now, I got a Bondtech wrench to tighten the heater, but I've got another heat block, another heat brake. Since I broke these, I grabbed 2 of them. So I'll have the ability to do a kind of a hot swap type setup, or possibly at some point do a dual extruder. Another cartridge style standard heater that we can work with the Marlin config, a PT1000 heater that we would be able to set up if we do a clipper configuration on this. I also found an all metal version of the extruder, which might be better since, well, the reason I had to replace the plastic extruder was it was getting worn through. And of course, the piece de resistance, a copper and hardened vanadium steel CHT nozzle. This is a 1.0 CHT nozzle. So what we were finding was that the 50-watt heater and the hardened Fadus nozzle, it was a 0.6 nozzle, we were getting really inconsistent extrusion. We thought it was the gear, so we took the tool head back off, replaced the gear, meaning the gear, right, the tooth gear, and we were still having some extrusion issues. So I told Clover, who was at the keyboard, I said, hey, bump it up to 220. As soon as he bumped it up to 220, we started getting consistent, or more consistent flow at least. So they were like, but it's PLA. And I'm like, yes. And you're going through a hardened steel volcano nozzle. You've got to bump the temps up when you're doing a hardened steel nozzle. So, but it is printing, so that is something that I'm looking forward to. I may go down and play with that some yesterday after I dropped Miss Dragon off at the train station. But anyhow, here's something I want to chat with you all about. So we already know we got a Centauri carbon coming from Elegoo that we've ordered, and I'm waiting on a Prusa Core 1 to come in, right? We also have some stuff sitting here from our good friends over at KB3D that I ordered. The stuff here is a Nebula assembly kit and the Nebula Plus frame kit. So if you're familiar with Nebula, or actually let me rephrase that, the 0G Mercury 1. The 0G Mercury 1 is a Core XY conversion for the Ender 5 platform. I'm gonna swirl you guys around here. Let me get a couple of things out of the way. And yes, this has turned into a horizontal surface, so I apologize. Turn around. There you go. Sitting on the floor here, once again, horizontal surface, is a full frame build for a 0G Mercury 1 that allows it to be enclosed. This I built under beta. I sourced the frame parts from Misumi, and I drilled and tapped it myself. That frame has finally been released and is called Nebula. So what I've got is a LDO space gray Nebula frame kit for the Ender 5 Plus downstairs that I have converted to a 0G Mercury 1, which means it's going to be rebuild and update time. I know for a fact that my parts, my printed parts, are old and that they've got newer versions out now. So this is probably not going to be gotten to before Rocky Mountain Rep Fest. But I'm going to start printing all the parts so that we can build up the frame and convert everything over to the Nebula platform on that particular frame, which means it can be enclosed. Now, I haven't bought the enclosed panels yet. That is something I still need to do. And I was just more or less waiting because I had various other things in this order and, you know, kind of spreading the cost out a little bit. Getting the enclosure for this particular size is going to be a few $100s, depending on which way I go, whether it's all white, all clear, all dark, or if I go hybrid, I think it's the most expensive option. And yes, there may be conversations had about either some superpower or Kraken motors for it when I go to do it. So hence another reason why I may be waiting until after Remurf to conversate with some people about other potential things that can go in this. The other stuff that is sitting over here in this little package and pile, once again from our good friends at KB3D. Gotta love the stickers. We're going to be adding stickers on everything soon. Now this is not a full and complete kit. This is going through the configurator because I had various things, but there were some things I was going to need, like the springs, the graphite infused bushings, the shaft that's going to ride inside said graphite bushing. So, who has any ideas of what this might be for? The springs in the graphite bushing should give you all a hint. And the fact I went through the KB3D configurator. And there's a plethora of different size CNC heat set inserts that I ordered at the same time. Anybody? I mean, this right here should definitely give you all a clue if you didn't have one by now. All right, I know I didn't lose everybody. Nobody has a suggestion. This is going to be for the Frax build that me and KB3D are going to do on stream. I just need to get with them and figure out a good time. But our 1515 extrusion tapped, I think it's black. Yep, standard black extrusion. But this is going to be for our frax build that we're going to do together. I need to get with him now that this has arrived and let him know that I have the stuff here so that we can schedule a time. It's most likely going to be on a Sunday evening, most likely. Okay. So we're going to be working on the Trident 350 today. Hey, Shrimp Father, how's it going, my friend? Hope you're doing well today. Before we actually start on the build, so now that we talked about we have a frax to do, we have the nebula frame that we're going to build and then do a full rebuild. I'll tear down and we'll do a full rebuild of the Mercury 1, or excuse me, the 0G Mercury 1.1 with Hydra that's sitting downstairs. And we will enclose that. The Optimus P1 has tickled an itch, or yeah, it's tickled something or caused an itch that needs to get scratched. And so we have some options. As you know, we've got a rat rig sitting right over here in a 300 size, right? But there are some other options out there. Some of those other options would be possibly a FISEC Venture XL, aka the FISEC version of a Voron Phoenix, or yeah, the Phoenix that hasn't been released yet. At least, yeah, I couldn't find it being released yet. This is a 600 by 600 by 600 volume printer. When I say volume, that is the build volume. It's 500 millimeters per second printing, has air filtration, 600 cube, smart touch interface. Large size for printing larger models. It does have the wheels. It will have a Nevermore Stealth Max air filter in the kit. 4 heated zone areas, and I believe it is set up that you can heat up just the side that you need, or the whole thing simultaneously. Yeah, and this is weird. It shows the 4 heat bed. It looks like another sheet of metal, so one large sheet with a magnet, and then the top. Doesn't sound that way in the BOM, but it's a little weird. So I'm not 100% sure there. A 7-inch touchscreen. A pre-assembled sheet metal enclosure. So my understanding is it comes like this, and then you finish building the rest, doing all the wiring and such. 4040 frame, 2020 for the gantry. CNC metal connecting parts for the XY, the idlers, all that. Drag chains. There is an enclosure with it. And kind of here's the size. Now this is the thing that kind of gets me. You're putting wheels on the printer, which means the anticipation is it's going to sit on the floor. It's like almost a meter cubed, right, in physical volume. It will have an upgrade path for IDEX or all-wheel drive. But why would you mount a 7-inch capacitive touchscreen at the bottom? We're going to have to see if that can be flipped around and used at the top somehow rather than at the bottom, because it would make more sense here, because it's going to be at like, wow, let me switch a camera real fast. There we go. Yeah. It's going to be about this tall. So it makes more sense to put the screen at this height, not down at the floor. And of course, it'll be a clipper, so you might not need the screen at all. Or if you do a screen, you might go something weird. Hey, Evil Diesel, how's it going? Hope you're doing well. But I'm kind of looking at this 600, 600, 600 printing area, CNC all metal gantry, 4040, 48 volt, 24 volt. So it's running 5160s. I believe it's running 5160s for all motors. There's a Logitech C270 cameras built in. I have no idea what a high power 63 amp, 40 amp contactor is unless they're trying to talk about like SSRs. Ergoba lighting, horizontal RGB lighting, 84 LEDs, and Stealth Burner logo 10 LEDs, and vertical lighting, 2 84 LEDs. So a lot of LEDs on this thing. There's more info out on the GitHub, but one of the there was something I was going to say. I'm not sure if it comes with printed parts or you have to print the parts. It's really weird the way the listing is, and when you look at the GitHub, really weird. Oh, hey, Petty Ruxpin, welcome on in, and thank you for the resubscribe. I appreciate that. 2 months in a row now. That is awesome. So yeah, I'm looking at this. There's a potential currently on sale, right? Or this feller. Go away. And I know this is a name that can be good or bad. But this is a 600 cube volume printer. Once again, there's that price. This printer is fully enclosed, and rather than linear rails, it uses this type of setup. It's like an extrusion that has linear rods built into the sides. Okay, and then it has the metal rollers that go on it. The other thing that you'll notice on the edge of this picture here, these are ball screws, not lead screws. So here we're running, this is a flying gantry. This is a oversized 2.4 with 9mm belts. And it's a flying gantry style. And I would have to show you in the assembly manual. But the, why is it not letting me go back to the other picture? Anyhow, the motors for the Z are mounted up here at the top, and they're geared. Okay, they're geared motors, and there's one on each corner for the Z axis. Okay, so they're larger size geared motors, belted Z, right, just like a 2.4. Yeah, so here's kind of the trade-offs. Well, not necessarily the trade-offs, but the differences. So this one has 4 geared motors for the Z, and it's geared ratio on those motors. It is set up for just 2 motors in the back, standard Core XY. There is going to be options down the road to make this IDEX and to make all-wheel drive options for it. So that would be interesting. This one's a bigger printer, It's still obviously using 2040 for that bed system because this is the Z. So it's using 2040 to build the bed frame and uses ball screws. So it has 4 of these rails and 4 ball screws. So 2 on each side. Hey, Westery One. How's it going, sis? It is running Clipper. Has this weird interface up here, but it is running Clipper. Okay. And an upside down screen. That's awesome. It does have these removable side panels. There's a lower panel and then this top little panel where the gantry goes. Double doors to be able to get into it. There's a couple of different versions. This one I'm looking at right now is the fully enclosed version of the printer. There is a open frame version, a enclosed version, which doesn't have that little top hat piece, and then a fully enclosed version. It's using Clipper, can be remotely controlled, ceramic heating, so it goes up to a 320C, uses a 3D touch for leveling. We can always change that. Dual drive extruder, I think it's along the lines of a BMG knockoff. LED strip lighting, Core XY printing structure, all metal OSG external dual axis metal guide rails, and that's for the X, the Y, and the Z. X and Y uses 42 stepper motor, high speed motors, so kind of the standard. Large fixed foot cups, blah, blah, blah. This is kind of the open air scheme, though even the videos they'll show later on, if you look at them, they don't use these large cross members. They're smaller corner cross members that give you greater accessibility. PEI sheet. I think this is one monolithic heater. So you can see there's a difference in price. If you get the standard open, it's this price. Where, as you see up top, if you do something like with an enclosure, that price will change, and fully enclosed, as we saw up here, that price does change a bit, right? And darn it, Balana, stop opening. Kind of goes through installing everything. You do have to build this printer up. It is flat packed. You do have to put it together. Same thing on the other one. We're going to have to build it, and neither one of these will be able to be built in this room. It's too big. If I build it here, I can't move it out of here. So we would definitely have to build that down in the garage once I get room for the garage. Yeah, so there's pros and cons to each of them. It looks like the sides on this are, I'll say, steel, where they're steel, they're not see-through, obviously. This will be a fully enclosed thing. Where on the other printer, it would be widely available. This does have these adjusters on the back that you can access through the back of the enclosure. It's at the back side of the printer. This is your tensioning for your Core XY belts. Yeah, faster heater or heating. It's an AC bed heater, which means it's probably going to suck some heat. These are the high power stepper motors, and this obviously is a rendering, but looking at this would be something past an EMA 23 from the looks of it, and ball screws. So yeah, and the ball screws are weird because it looks like you have one motor per each ball screw. So if you can see right up here, there's a motor on each side that's belted driving the ball screw, but there's also synchronizing belts at the bottom on each side to try and keep these two ball screws in sync. Pretty interesting. And I think these might be here and required on the open air version to help give it additional rigidity. Once again, here's those linear rod rail type setups. Yeah. So the goal here would be to have something that we can build larger with, but not necessarily something that will be, like you said, it's probably not something we'll be using day to day, but I will need some larger size capable printers. Otherwise, I'm printing a bunch of smaller things and having to figure out how to put them together. And it's going to be one or the other, not both. So I need to try and make my decision. I think going with the Adventure XL, one, it's a little bit less expensive, but I'll also have greater modability because of the way, I mean, it's a Voron. For all intents and purposes, it's a Voron, right? Speaking of Vorons, we've been working on a Voron that I need to pick back up here. Oh. Somebody finds my kidney and wants to foot the bill for the next hernia operation, that would be great. So we've been working on this, and as you can see, there's a gaping hole here. Off stream the other night, well, at the end of the stream, we did get the mount finished printing, so I put that on. Yes, it's red. Yes, it's going to be under the deck panel, and it's not going to matter that it doesn't match the color scheme. I did add my 7 motors. Once again, we'll have A and B. Well, 1, 2, 3, 4 for the A and B, or AB, Z1, Z2, Z3, and then the other XY ones. I don't know. We'll see how we wind up setting it up. The orientation is going to be a little bit different than we had with the M5P, just because of the way things were. On the M5P, basically the stepper drivers were down here and a lot of the power was over here. Now the stepper drivers are on this side. The power is down here. We should have enough to run all of our cables the same way or very close thereabouts. We would need to set this on there, and we're going to set it on there like this. This may go away or get slightly adjusted. I think it'll be more slightly adjusted. Now, currently I have 2 different CAN bus cables set up. I'm only going to need one, and we're going to have to change the way that it connects because my CAN bus is way over here. And I don't think either one of these is going to have the reach to do power and come over. So we'll have to make some room. But this, that is the right way, right? Yes. This will go there. Dang it. This is why I don't like these, because you basically are hooking this side and having to pull that spring to get the other side to clip in. And I find it's more of a pain sometimes to get this done on a DIN rail. Okay, there we go. That worked. This being the, I believe this was the bed. Yes, this is the SSR from the bed. This is obviously going to be short. We can remake these cables though because it's coming from the SSR. Really easy to do. Hey, Giggy Jack, welcome in. You're printing a few things? I am too, and apparently I started to print on the X1 Carbon and then it decided to pop my circuit breaker. So we had a weird start to the beginning of the stream because of that. The other thing that we're going to have to do is work on our motor cabling and getting that pulled around and down here and cut to size. But that will be one of the things we'll work on a little bit, well, as we start to get everything wired up. So this is, what do we got? What do we got? We've got, this is the cable that goes to the B motor. So this is our standard B motor wire here. We'll start getting some of these installed and routed. We'll come down here. We'll have some extra, but B, then A. This will be our B motor. Now, if you remember, these wires right here are RGB, and we currently only have one RGB connector on this board, where on the last board we had two. So we're going to have to figure out how to daisy chain those together somehow. So we got the B motor. The A motor will be the back left motor, and the other one that will use the pre-made cable. Now this, we're going to connect here. Maybe, if I can get my wires lined up. And I will admit that I'm trying to slow roll a little bit, because at some point we're going to have to get to the CAN bus wiring, and I'm still thinking how I want to do the CAN bus wiring. Because when we get to the CAN bus, we're going to need to figure out if we're going to keep our long run all the way to the top and stay inside the printer, or use our one that we routed to the back panel and be able to remove this wire as needed. And I think what I'm going to do right now is pull this out, which is the, why not? We're just going to pull things. This is the actual cable that goes around to the tool head right now. We're going to pull that because I think I'm going to wind up just cutting it and using it as an external to internal, because of the way the CNC parts work. There's not going to be a space to route. Well, that's going to be great, because that's going to give me the longest cable. That one's pull out as well. No. Stop it. Having brain farts. Bear with me. Okay. So the existing CAN bus cable was going through with a cable gland in the back right-hand corner. This particular CNC kit does not have a provision for any type of cable gland to be added. So what that means is we will not be able to really route our CAN bus up into one corner or the other and over to the tool head. So what I will do is what I've done on some previous builds, and on the back panel where you normally have the access for the air filtration system, which I've yet to actually put on any of my Voron builds. I've always gone with the Nevermore. when you there are panels that you can put in place there that will allow you to run your like your PTFE tube and then also a cable gland through, so that you can get your all of your CAN bus wiring through neatly. So we'll just come through here and kind of shove our wires down in here, make this one semi nice. Okay, done. Be working on redoing all of this wiring here anyhow. So make room. We'll get this pushed through and basically get this down here so that it's done and out of the way. If it will stay down and out of the way. These are the wires for the bed. I'll go ahead and pull these because we won't be able to use them. We're going to have to make new ones of these. So I'm just going to run these out of the way for the moment. This is the bed thermistor that we had extended. And our thermistors, I think our thermistors are all over here. No, these are fans. These are fans. Thermistors might be right here. So we'll be able to bring that down and over. That will still work. CAN bus wiring, because our CAN is over here. That should still work. We'll be able to redo the wire some. Change the length. That back in there. This is wire feeding the Wago. Okay. That there for the time being. So we got that one. I started to bring this one through. This is going to be the A motor wire. So one is B, one is A. A little bit of excess here. How do I want to do this? I might just take this all the way over and back. Right, here we go. Oops. Don't really want to cut these just yet. I'll leave them long. Try to just run them through. Okay. Z motors. Front right. This should be Z0, right? Yes, it is. Z0. All right. So we got Z0 in. So Z0, Z1 should be the back middle. Z1. Bring this one down. Do our standard tiny loop. Now we're going to skip one of the connectors and go into the next one. What that does is your Z connector, your third connector here, is always a parallel. So then this one is the fourth one. So you always want to leave one. You can either bring this one up and leave the gap between B and A so your three Z motors are together, or just remember to leave a gap there. And then this will be the last Z motor. We'll bring this around, up, and go into the next motor slot. And just like that, we've got our Z motors. Now our other two motors, we're going to have to bring long ways. We're going to route them from here. We're going to go up, across the top, down. We'll kind of loop it down around to join with the other motors, where we can start getting them into our tie downs. So made this one a little bit too tight. There we go. Give me the ability to pull it down a little bit closer. Okay. And these were the ones we made up on stream the other day. So you remember, right, we cut the ends off here, which were the 6-pin, and made our pigtails. So that they'll match up with the pigtails on the wiring over here, making sure that all the wires match up the same way. And we really need to bring these wires up to make clearance room for our gantry over here. So we're going to try and bring this up and around. And what I'll do is I've got some, some gap filler there, or it's vinyl, what do they call that stuff? I was going to say gap filler, but it's a vinyl material that you put into your 20/20, 30/30, 40/40 extrusions, whatever, and it covers everything up nicely and makes it look pretty. So I've got a bunch of that as soon as I find where I have it at. And we'll put that in, and that will make things a little bit nicer and keep that cable out of the way without having to use a bunch of zip ties. Too many boxes of things around. I thought at one point we had discussed, and I had agreed that I was going to clean up and reorganize. That seems to have fallen short again. Like I feel like I started to, and then somehow I stopped. I know the size, I know the shape that I'm looking for. And there we go. So we're going to use some of this, and we'll just take some of this and put it right down into our channel, and that will cover up and hold our cable in. Once again, we're going to take some of this, we're going to bring our cable around, and we'll just use our 20/20 extrusion stuff. And this will give us the ability to cover up our wires and make it a little bit nicer as we route our wires around. Kind of keep them out of the way. Now this wire is going to have to come down alongside this motor and kind of wrap around as tightly as we can get it, possibly even around the back side to come down and join there. We'll need a little bit right here. Burn it. You've been saying that for 2 years. Thanks, Evil Diesel. And yeah, Petty, he gets to call me out. My old airman gets to call the sergeant out occasionally. Not that I'm going to say he's right at any point in time, but he gets to call me out every once in a while. I'll give him that leeway. And this is going to be a weird, because we need to kind of keep it down and out of the way as much as possible. Kind of do like this. And I will put a zip tie in here to start trying to hold this up. Because I believe this is all I'm going to have are these wires here. If I don't, my daughter will bug them. That is true. That is true. Evil Diesel's spawn will give me crap. She thinks she's special like that, but I give it back to her. Always wins in the end. I won't give her that much, but we'll get more of our zip ties out. We'll get this last zip tie down here. Like I said, I believe we're good. Why? It just went to sleep on me. Which one went to sleep? That one? There we go. You get to see my bright face again. All right. So that's there. We'll bring this around underneath that ground wire. Same place. Through here. Down. Give this a loop. Now, we're going to put the, which one is this? This is the we'll call it A1 motor, the front left. We're going to skip one and it'll go here. Whoops, skip. We'll go there. So on this board, there's a 2-pin fan header right here. This is the next motor and then another motor right here. And you can't see a darn thing because I'm on a wrong view. Okay, so bench side. Bring you there. Maybe we'll zoom you in a bit. Oh, that's a lot. Okay. So right here, right next to that is a 2-pin connector for a fan header. This is the next motor, and then the next motor, and then this is the last motor that we don't have anything in right now. So what we're going to do is I'm going to bring this down, and this is going to skip one and going up here. Because this is the, we'll call it the A2 motor or Y2 motor, Y1 motor, however you want to call it. It's the opposite corner to the standard rear right. So this would be the front left motor. Doesn't really matter what order you put it in as long as you know what order you put it in. Okay. Okay. What next? We need to do the other motor or other long cable. Same type of thing we're going to do. It's just on the lowest motor over here. Pigtail, thank you. And once again, I'm trying to bring my wires up in such a way so they're going up, which kind of gets them out of the way. Right, we don't want our motor wires to be able to dangle down and get caught up in our tool head. So we want to bring them up and run them along the top edge of the printer. And we're using our, once again, we're using our vinyl slot cover here to work that motor cable in. Get that over there. Figure that out. Figure this out. We'll go to about there. Need a short length of this. Evil Diesel, were you over at the game store today? I thought you were supposed to be down there doing a game prototype. Okay. Now we're going to bring this around the back side of the motor and then run it down here with the other motor. I'm trying to keep it out of the way as much as possible. Run a zip tie through. So this is what still worries me a little bit because we can't go around the back side of the motor, but we also have to be careful because the gantry, as it comes back, get this out of the way. The gantry, as it comes back, you know, we got to be careful that it doesn't smack into that. It might rub into it, but it'll be okay. It's far enough out of the way So we'll just continue to zip tie this in. Going down the side here. Yes, Mrs. Dragon is on her side. The girls are ganging up on me. I'm sure if Pezliz and Royal Nomi were in the conversation, they would gang up on me too. They were conspiring at Rocky Mountain last year, so I'm sure they'll conspire at Rocky Mountain again this year. Hey, Layers with Lily, how's it going? I hope you are doing well this fine day. I'm going to go ahead and clip the zip ties, or the tails on the zip ties, I should say. Keep them flush. Keep them flush. Last thing you want to do is get your hand sliced open on a zip tie. It sucks. It is annoying. Especially when you're reaching into something like a cabinet, a printer cabinet, or a printer cabinet. When you're reaching into a network cabinet and you're not realizing it and you catch yourself on a zip tie and slice yourself open. Because like I said, you don't realize it at the time until you pull your hand out and you realize you've been bleeding all over everything for a while. People that come in to do cabling after you kind of get mad when they see blood everywhere. Okay, get that one plugged in. There we go. Bring that one down there. Like I said, we're just going to kind of keep looping things around, keeping them out of the way. There we go. I may put this one on just a little bit, slide it over some. Why did you jump out of your... Okay, so we've got our motors in. Now what do we need to do? Ergobuzz extra, in my opinion. I don't necessarily need to do that right off the bat. This is our Y end stop. So we'll need to get this routed up here with everything. And our Y end stop is going to be up here. I think it'll go there. We'll double check that in a second. I think it goes there. Play nicely, cables. Okay. Like I said, we'll double check that in a second. Let's see. Oh, where's my Adobe Reader? Adobe Reader. Open up that one. And a little desk scroll, and then I'll throw this up on the screen. Make it bigger. And guy can see. There. Okay, so here's our wiring diagram. Hey, Eagle the Dragon, how's it going? Welcome on in. Yes, this is a nozzle desk mat. This is, as Pezla stated, a 3D print SOS desk mat. It's got all kinds of different nozzle designs on it. I also have a coffee cup, same type of thing. So, yep. Don't forget about your Digital Dragon 3D coffee cup. Do you have a preferred angle to cut your zip ties on? Flush with the head. Zip ties are cheap. You can cut them off, but if you leave any type of tail, and I'll show you what I mean. Okay? You will get people that will run their zip tie, right? And then they'll just reach in there and they'll cut it short, like that. You do not understand how incredibly sharp this plastic is right here until you drag a forearm across it and you wind up bleeding like a stuck pig. Always cut them flush with the top of the head. If you need to, if for whatever reason you need to get back in here, cut it, replace it. These things are like half a cent a piece. Cut them flush every single time. And yes, there are times where I go through and I cut these things back off and replace them 4 or 5 times. It doesn't matter. They're cheap enough. Hey Eagle, how's it going? Glad you guys are doing good. Yeah, like working on cheap computers, exactly. They do that the same way. Cheap cases, cheap computers. That's why when I buy a case, I will literally sit there and like go around the edges, just making sure that they need to, if anything needs to be deburred. Because the last thing you want to do is just start digging around in there and all of a sudden you're slicing yourself on a thin piece of stainless steel or something. I've also had, oh, what am I thinking of? These things too. These things, you gotta run a file on these troughs. When you cut them, run a file on the edge. Clean up that edge. Anytime you cut plastic, clean up the edge. You'd be surprised how many times you will cut yourself on a plastic edge of something. Okay, we're looking at the end stops. And this is the end stops section right here. There we go, end stops. So motor 1 stop, motor 2 stop. So we went into the second one, which would be the motor 2 stop, which is X, Y, for lack of better terms. So we're good there. We're in the right place for that end stop. Go in there. Stay in there, please. Thank you. We've got some fans. So this is the blue and white is the fan for our, whatchamacallit, our bento box. We can loop that around, and our fans are over here. We'll bring this up and bring this into, say, fan 1. Then this one is the 3-way. So what I've done here is, this is an LDO way of doing things. They've got the 3-way parallel plug. So I bring the 60-20 fan into one, 60-20 fan into the other, and then out of the middle I come up, and this is going to be the one that goes up to the main board. I'll just bring this around, pop it in, and this is going to go into fan 0. And then maybe put it in the right direction and it'll go in, I guarantee you. There we go. So fan 0 is our controller fans. Fan 1 is our bento box fan. And we do that the same way. So here's the 3-way for my bento box. So that way I don't have to cut and try and blend the wires together or anything like that. I just use these 3-ways, bring your 2 fans into one, and come out with the other fan. So that's what we're looking like so far. So we've got our 2 fans in here. We've got all of our motors on this side. We've got our Y end stop. This was power going into the board. So we'll need to bring that in. Into our board, we need to go into power here and power here. And then we'll do bed out to the bed out. I don't think we technically have to come into bed power because we're using, like every once in a while on these, you have to go into bed power. Like you have to bring power in. Otherwise, it just says like, no, there's no bed. So in other words, you have to have something in bed power before bed out even acts. That would be why this, I don't think, was actually into bed power. I think that was into an HE. Let me double check on the Manta M8P. High voltage. No, it was going to a bed out. Yeah, it was going to a bed out, or at least a higher voltage output. So before we had power on the HE5, we had our power coming in. Whoops. We had our power coming in here, and then we had our bed coming out here. So what we'll do is we'll bring this down. Like I said, we're going to have to redo the bed wires so we can bring it down to bed out. Alternatively, if we need to, we can come into one of the HEs over here, the hot end fans. Sorry. So we can either come out of bed out, or if it gives us any problems there, we can just run it over here and come in over here with a ferrule. But we're going to need to redo our wires so that we can get our bed power over. And what I might do is just see how long these are compared to this. Can this run? No, these would be short to get up to the SSR anyway. So we're going to have to redo some of our wires here. Let me pull us back out a little bit so we're not as focused in. There we go. So we're going to need to redo these wires. Once again, we have one set of our DCs coming up to a 24 volt for our CAN bus. The other thing that we could do is pop this off, slide our board up, do our Wagos down here, and bring our 24 volt in and do it that way. Why would we, oh, that's right, we're just switching on with the, and that'll give us the ability to do some smaller jumpers over here. Our CAN bus is up here. Yeah, I think that's what we're gonna do. Yeah, I kind of like that idea. So which way do you go? There we go. We'll pop this off. We'll be able to pull these wires down, off. Keep going. You. Okay. So here's our 24 volt. We can slide this up like so. Slide that up. There should be nothing, nothing except where I ran those through. Pull this up. That one up. We're just going to continue to work our wires around, trying to get things cleaned up as best as we can, untangled as best as we can. Okay. This once again is our bed thermistor, so by moving this up, it may actually get us closer to be able to hit our bed thermistor as well. That there, so I can move that back out of the way. So by moving this down here, we'll be able to come out and go into, we have to at least bring power into the motor power and power for the board itself. And then the bed out will come here. It really sucks that that's not gonna stay tight up there, sagging. But we'll put this down here, and actually what I'm gonna do is, this is a 3-way. I'll switch this over to a 5-way, which will give me more 24 volt outputs that I can plug things into. Put the 3-ways away. We'll grab a couple of 5-ways. Hopefully without dumping everything in here. Okay, so there we go. Like I said, we can slide this up. We'll put this down here. And we'll be able to go in here, or we can even drop it down here on this side. Probably would be the better way. Drop it down here. That way it's out of the way if this continues to slide down. Put that back over there. Get this out so I can sit down here, and we're going to have to figure out, we're going to need ferrules, and some fork connectors. Good thing is we got plenty of those. Now the question is, where am I going to sit everything? Do this. There's those 3 sets. Dropped one over here, so grab that. Now, hopefully, because we're close now, I'll be able to just jumper some of these wires over, and I won't have to cut any new wire there. Once again, this is my 24 volt coming out. This was also 24 volt coming out, right? Yeah, so I've got 2 sets of 24 volt coming out, so I really just need the one. I'll cut this about right here. Let's put some ferrules on that. And for those of you that remember when I knocked all of my ferrules over, I did go in and get them all resorted out. That was fun. Sitting here on stream, or not on stream, but listening to someone else stream and just sitting here digging my ferrules out with tweezers. It was great. Hey, Steve Builds, how's it going? Long time no see. We are trying to rewire up our Trident here. So we've been doing some upgrades to the Trident. We installed a Siboor CNC all-wheel drive kit. And this particular machine had a Manta M8P in it. So we obviously weren't going to have enough motor stepper slots. So we replaced on that with a Manta M8P to give us the proper number of motors and stuff. And which way we want? Let's do. Positive there, negative there. Now, we aren't going to need this connection anymore, so we can actually take this one completely off. So Steve, quick question for you. Running the board, 6 motors, and what we got? The board, 6 motors, fans, stuff like that. Would a 200 watt power supply work, or should I swap the UHP 200 out for a UHP 300? Or 350 actually is what I got. Do you think I should swap this out? This is all-wheel drive, so it's got 4 motors for the gantry. Actually, so 4 motors for the gantry, 3 motors for the bottom, or for the beds. That's 7 motors, fans. Yeah, 7 motors, you're not sure. I guess we can give it a shot, and if it does draw too much, then it's easy enough to swap it out. But what I'm going to be able to do is I'm just going to take the rest of these cables here and just keep cutting them down. like I said, we need to come into power. Yes, it helps if I undo these. We'll need to come into power and the motor power side. And since I've got the connection to do so, I'll go ahead and bring it into bed as well. So this particular build, Steve, we've done several upgrades. This was my standard Trident 350. Like I said, built from some DFH kits. And it's now going to be rocking all-wheel drive CNC 9mm belts. We're going to swap out to a 330 power supply. Because as soon as I was getting ready to say the next thing, this is why. A Takeoff tool head and a Chube. And the Chube's got a large heater in it. So yeah, I'm going to swap this out for a 350. All right. This out there. We will swap that out because as soon as I started thinking about it, it was like, yeah, we're going to throw a Chube on it. We'll need a 350. Yeah, they got expensive, didn't they? I mean, they're already more expensive than the LRS, but the UHPs got expensive with the tariffs. It's actually cheaper than ordering it 18 months ago. It's been a while since I've ordered some though, so yeah, that might be right. Um, Steve, are you streaming tomorrow or are you traveling to Rapid? Oops, guess we'll be skipping that one. We'll go in the middle. Maybe we'll do that one for our Canva. Enter into, right? Apparently I'm hard time. You go in. Oh, since I have these, is I'll go ahead and these in the next one. Cut them in the opposite direction. Ooh, yeah. Pull those out. We'll put some fork spade connectors on the other side. remember when you're doing your spade connectors, you don't have to take off a whole lot. When you're doing your ferrules, you kind of do, but on your spade connectors, you don't. Spade or fork connectors, I should say. Hey, thanks for the alert, Jedi Spidey. Okay. Negative. Okay. And one more, we'll do one type on each side. We'll be able to add it into the bed in. That way we can use the bed out to trigger the SSR, or we can not use these and go into, pick one of the other connectors. You have your oldest son visiting from Virginia, so hanging out today. Nice. What part of Virginia, if I can ask? My brother lives in the Fredericksburg area. You're doing the Tic Tac builds tomorrow? Nice. Very nice. That'll be interesting. So, you'll be able to give an opinion on this, Steve. I'm looking at for a later project. Not, it's definitely going to be a after Midwest, right? But there are two printers that I'm kind of looking at right now, and I want to get your opinion on one of them, or both of them actually. Let me grab my mouse around here. So, option one for a large size printer, this would be a 600, both of these are 600 cube build volumes, would be the Tronxy Viho, fully enclosed. This uses you know, lot of, we'll say, basic standard stuff. 320 hot end, but it uses this type of rail system. I think they call it OSG. It's got basically chrome rods on the side of an extrusion, and it uses metal roller bearings to slide up and down on that. And as you can see in the side here, it has ball screws. So the setup here would be ball screws. You can kind of see it here. There's a rail and a ball screw on each of the four corners for the bed. Each of the ball screws has its own motor at the top, the belted motor. So it's a geared belt. But at the bottom, they're also synchronized linked at the bottom. Core XY, I believe it's 9 or 10 millimeter belts on this. But they sell this in a couple different ways. So this is like the Pro open air. Then there's a enclosure where it has basically the four walls and open top, and then the full enclosure with the top, which is what I would wind up getting. Yeah, it's 3D touch. Ceramic hot end goes up to 320. It does say it's running clipper. Kind of set up here. Has adjusters for tensioning the XY belts. And then the other option is this kit here, which I don't know why it won't let me, which may look familiar. And this is a FISEC kit that is basically their version of the Phoenix. So this is 40/40 frame with, I believe from the looks of it, it's 20/20 extrusion for the gantry. Geared motors from the top for the 4 Z belts. All CNC'd parts for the XY gantry. CNC idler for the Z-axis. So it looks pretty decent. But I know that there may have been some changes since Phoenix still not out. So I guess that was my thought is, did you have any strong feelings, especially about this particular one, since I know you've been working on Phoenix? So this is running 5160 48 volt drivers on all the motors, 24 volt for the board. It's a spider board, 2.5 amp, high temp, high torque motors. Hey Waters, how's it going? Yeah. So I'm definitely not pulling the trigger on either one of these. And I know there's a lot of people that aren't fan of Tronxy or FISEC. But I'm looking at one of these. Now this is supposed to have an ability for a IDEX or all-wheel drive gantry setup down the road, or you can probably do it yourself as well. Now you haven't been here recently, Steve, so we have been looking and working on one of these, the one on the right here. Gosh, stop. So this is the Optimus P1 on the left, the P1 Pro on the right. Waters, who just popped in and went into lurk mode, he he's one of the folks that works over at Ecovate 3D here in Raleigh, and they had one of these dropped off at their shop. And my understanding is, if Waters is actually listening, it was donated to the shop. So this is 600 by 600 by 1,000 or 1,100 millimeters, depending on who you talk to. It's huge. The wiring was a mess on it. I've spent a couple of streams cleaning up all the wiring on this. Oh dang, I thought we had more on that. I must not be on the right page. There we go. Is this a better one? A little bit better. So this thing has NEMA 23 stepper motors running at 4.8 amps, driving 16 millimeter ball screws for the bed. All linear rails, MGN 16 linear rails everywhere. This thing is massive. It's printing on glass, which is perfectly fine. Yeah, MGN 16, SFU 1610 ball screws. The thing is a beast, but it prints slow as heck. It's running custom Marlin. There's kind of a picture of it with I'll say a normal height guy standing next to it. It's a beast. We've got it running. Looks like they got it. We got it pushing plastic on Wednesday. Last night they got it. They sent me a picture. They did a benchy on it, standard size benchy, and it layer shift at the hull line. But at least it printed. It runs a volcano nozzle. It's running on an MKS Jan board. It's really weird. So like X is a 2208. Because there's a single motor on X. Y is running a 2209. There's dual Y motors. So it's not Core XY, but it's, think of, like an Ender 5 type setup thing. Z goes out to external, like CNC style stepper motors. 2 of those, 1 for each motor. And then E looks like a DRV 8825. It's really weird. And they're all set up in dumb mode. So we're about ready to, I don't know, repurpose the board that came out of this, because we only need 4 drivers, and clipperize the darn thing, because the Marlin firmware is very bastardized, and the company no longer, so FebTop, who made the printer, is no longer there. Optimus 3DP, you can get parts from them if they have them in stock. Like, they're not making any more, so if they have some, you can buy some type thing. Yeah, it's really wonky and weird. Sorry, I'm thinking something through in my head. I need to pull this out verbally without pulling out a bunch of other cables. But yeah, that's a fun little printer. Well, not little, but that's a fun printer that we've been playing with. And it got me on that itch of having a larger printer for some larger things here at the house. So but yeah, that's kind of where I'm at there. Let me go back to the bench side view here. Okay, so this is our CAN bus cable that I believe was routing Yeah, this is the one that goes to my rear mounted 4-pin. And like I said, I believe this is what we're going to use going forward here, because the words on stream. I believe we're going to use that because of the way the I'm going to have to route the CAN bus cable. This is going to be the best way to go for me. Now, what I'm going to have to do is cut this and actually shorten this quite a bit. We're going to bring a CAN wire up here because our CAN bus connection, CAN high low, is somewhere up here. And then our power is going to be down here. So I could really do this the wonky way and just bring it straight to power, but I'll leave it this way. I need to strip it back probably that far. So I'm just going to lop these cables off, because having the frayed ends isn't going to help when I go to try and strip this much coating on the wire. Let me put a couple of things away. Clean up the workspace. Mouse out of the way. And we'll come in here and start taking this off in chunks. Now, when you're trying to pull off insulation on a large cable like this, do it in smaller chunks. If you try and do it one big chunk at a time, you will stretch and pull the cables internal, and you'll have larger problems. So strip it in smaller segments. You hate when printers use non-standard parts. Yeah, in this case, that FebTop printer, there's just some weird design things to it that just kind of made you go, huh? And we're working around some of those, and we're going to fix those. In this case, this printer enables the use of both a volcano tool head and a laser module. And I'm not sure if you guys have heard me over the last couple of days since the H2D came out. Don't put a laser module in your 3D printer. Either get a laser and get a 3D printer, but don't get a laser and 3D printer. Especially not an enclosed one, because there's just no need for it. You're going to be depositing a ton of soot into your printer that doesn't need to be there, and it's bad, right? Hey, Waters, are you down at the shop today, or are you at home today? I may swing by the shop tomorrow. I got to drop Miss Dragon off at the train station in the morning. And then I may swing by there. Spent today with your wife? Good man. Good man. Yeah, that Wednesday when we were working on trying to get the printer, we kept seeing the light at the end of the tunnel, so we kept working on it, and we left at like 11 p.m. It's in Raleigh, so I didn't get home till after midnight. I got home, gave my wife a kiss, and went straight to bed. We were all getting the, are you coming home? I shouldn't say all of us. Clover wasn't, but me and Waters were definitely getting the, are you coming home? Like, I let you go out and play, but not not the entire night type of thing. And Waters, I do want to double check. The benchtop is actually donated to Echovate, right? That was a straight up, I am super frustrated. I don't want this thing anymore. You meant a lot, be a lot more productive than you were. Yeah. We had thoughts of being productive ourselves today. We weren't. Okay, so we need to put some JST connectors on this end, and that'll be done. And then we'll need to run some signal cables for the SSR. We'll swap those out after I get these done. JST. This and yeah, I was just thinking that I probably drop her off and then go have some breakfast because I'm dropping her off at, I think I have to have her there by like 9 down at the train station. So I'll definitely go grab some breakfast before I head over because they're still not, you guys don't open till noon, if I remember right. All right, cruising girl. Your SVO4 uses a heat throat that is 8mm diameter when most, yep. So the heat throat here was shorter than a normal one. Like I got a replacement heat break because the heat break, you're going to love this. A 600 by 600 printer, it was configured with a 0.4 nozzle, volcano style, with a PTFE lined heat break, like full through to the top of the nozzle of the volcano nozzle. So I had gotten a titanium heat break for it that I crashed into the bed when we were trying to set Z offset, and we snapped it. So then we wound up putting back the old heat break after swapping out PTFE tube for some Capricorn tube, but it still you know, it says it's an enclosed ABS machine, yet you've got PTFE lined hot end. It makes zero sense to me. Waters is going to Rapid this week, along with, I believe Waters is going. I know Beverly's going. And I know a couple people from Echovate are going. I was going to try and tag along, and then my backup at work decided to resign, which I don't begrudge him. I understand his reasonings and stuff. We talked about it. But that means I have no backup, which means I couldn't really go to the show. So that kind of sucked. All right, I need to figure out where those two wires need to go. So once again, we've got, flip over here and get rid of that. Need this. So we need the bed thermistor. I believe this is our set of thermistors. Where's that? Thermistors. These are the thermistors over here. 3, 2, 1, 0, bed. So DB1 all the way over to the side by the cap is the bed thermistor. This is the thermistor for the bed. It's going to come all the way over here to that connection. Not that you can see which connection I just shoved that into. So just pop that in there. Now the other thing we need is the CAN bus, and the CAN bus is this one right here. So our CAN bus wire needs to come in here. And the way I wire up my CAN bus is yellow like the sun, green like the grass. So yellow, high for sun, green, low for grass, right? My way of thinking about it. The RGB connector, level signal. For RGB is thermistor rows. It's going to be the middle connector right here. Which way does it go? That way. So that would be the RGB. And because I'm running two different RGB sticks, and there's only one RGB connector here, I'm now going to be short a light. So not sure how concerned I am about that at this point in time. I'll just run it with the one light, whichever one I just plugged in. It should be the one on the right hand side of the machine versus the left. And this one we'll have to figure out. We'll have to figure out a way of getting the extra light going. I'm sure somewhere I can find a, kind of like we did a splitter for the fans, I'm sure I can find something for splitting out the whatchamacallits, the RGB connector. Yep, can't be mad, won't be mad. He did what he needed to do for his health and his family, so I am definitely cool with that decision. Now, I need to do up some long wires here. Let's see, what do I want to do that? Let me get down into this box. Oh. But we don't need, because this is just going to be a trigger. One, we don't have to come off the bed. We can come off of one of the other connectors, like one of the AT connectors, which means we're also just sending signal wires, so we don't need like a hefty wire to do this with. 4-volt, 24 or 24, 24, 18 gauge. Use some 18 gauge wire here. Really not needed, but we'll make the run somewhat decent. So if we're going to trigger this on bed out, we'll go ahead and do one side of this, figure out the length, and we'll custom make the run. So we'll need fork connector on one end. Actually, we'll need fork connector on both ends. Fork connector on both ends. Not. Apparently I do not. Good thing I have an entire bag of them sitting right next to me. Is the one end will be the negative. Around, go up, over, be about there. Not a problem. So you're going to be at Rapid then, what I just heard. So yeah, I'd really like to have gone, but like I said, with the guy at work ducking, I can't. So don't mean ducking like in a bad way. Because trust me, I kind of love to do the same thing. It's not going to happen yet. Need a few more stars to align first. End up, you come back. Make sure your crimps are nice and tight. Not your wire. This one down in here for now. You get to leave while they try and figure out how to do anything and all. Yep. Yeah, we just did a major upgrade of our ERP system. All the fanfare, oh, another successful ERP migration or update or whatever. And I'm like, oh, great. Does it work any better? Can we, really good if it's not actually any better. All right, we'll come down through here. Brought up. And Steve, if you're still here, got another question to ask regarding fans and whether or not you've ever put like 12-volt PWM fans in series and run them at 24 off of a toolhead board. Because that's something that I'm trying to decide if it's something I want to do or if I should just make home runs all the way back to the board for a pair of 12-volt 3628 fans on my Takeoff toolhead. I think that is what Daniel did. I think I remember him saying that he wired all his straight back. Oh yeah. Gotta love when that happens. We're going to use this obscure system. It's going to be very secure, but we don't know if we can even make it run in our environment. Okay. That goes there. Pop that out, and I'm going to try and actually route it underneath like I wanted to. Or I let it flop out and put all the other wires in front of it. Okay. All of that is wired up. Like I said, I'm good without the I'm good without having the other RGB plugged in for the time being. It is definitely not a requirement. Not in the middle. Which one goes where? Maybe you're missing a couple of the other ones. I'll have to find those later. There. Really don't know what I did with the other ones. I'll find them later at some point. Okay, so I think we've got all of our connections done up except for the tool head, which is what we're going to need to run it next. And we will have to run a CAN bus, but we'll be able to terminate it outside the printer. And you guys let me mount that board and do all that wiring, and we didn't plug in the monitor, the screen. So now I get to see if I can pull this off and get the screen mounted without undoing half the wires here. Because it will go on the bottom side. You see if I can look at it from the other side. So we'll need to install the screen. SPI screen. Here we go. Because we're running a CB1, this will be an SPI display. If we were running a PM4, we could configure it with a standard DSI display, which, by the way, would definitely make life easier. I think we got that in there. I did get a good flash on the board, and I figured out what the issue was that I was having the other day, which was when you flash your board, run power from an actual power outlet, meaning run a 5-volt power source, not trying to run it from your computer, because your computer is then trying to connect serial over your USB cable, and it will not let you talk serial or find a serial port for your actual MCU. And before I forget, we're going to swap this over to the 350. So we'll take the connectors off this, and we will disconnect these. We'll pop this off. We'll swap the whatchamacallits over, the mounts over, and we will reinstall. Now on these, you've got to take the thing completely out, because the mounting holes are actually like tapered or fitted, which makes getting these screws back in so much fun. Come on. And hey, Jerry, how's it going? Welcome in. Thank you for the raid. How are you guys doing today? How was your stream? Normally I stream early in the day, but because of Polymakers Polypalooza, I held my stream off, and we decided to stream later today. So come on. No. Hey, Jose, how's it going? Glad to see you. Hey, Matt Owl, welcome in. You're interested in purchasing either a 300 Trident or a 2.4. Which do you think is the best flexibility for future upgrades and options like tool heads, etc.? Either. And here's the reason why. It uses the same exact gantry and toolhead system. The only difference is on a Trident, your gantry is fixed. On a 2.4, your gantry moves. The only difference. So either one, it's whether or not you want your print bed to be at the bottom and your gantry to move, or if you want the rigidity in your gantry and you want your bed to move up and down. Either system works perfectly fine. Okay, so we're going to pop this off, and we need a 2mm screw so that we can pop this mount off. We don't even have to unscrew it all the way. We're just going to crack it off a bit. And we can pull that off. Just going in the same direction and it should fit right back on. And it won't. Oh, I guess this one's a little bit wider. Dang, I thought the mounts were going to work the same. Darn it. Okay, now I've got to go print some mounts for a UHP 350. I don't know why I just took that off because it won't work. So the reason I'm definitely going to switch over to the UHP 350 is we've now added 2 more motors to this because we're going to a all-wheel drive, and with our Chube Takeoff, I believe I've put a 100-watt heater in it because it's a Chube. Like, why not? So we're definitely going to need to go up in size. Now I think I've got a 350 LRS, but that's not going to fit here with this in the way. So we're definitely, where are those other 2 conduit bars? Not there. It's going to drive me insane where those conduit covers are. Because now I want to cover it up because that keeps popping out. Ay, 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 ay. Oh, you know what? There they are. We'll pop these in and we'll cover this up. And one of the reasons why I'm going to want to get things covered up is so that I can apply power to this while it's sitting up like this, because I want to be able to look at this when we start to configure some things. And we'll get some of this set up ahead of time. But we're going to have to redo or print off a new power supply mount. I guess we could probably fit this, just put it back up on its top and work toolhead stuff. But let me find a UHP 350 DIN rail mount real fast that I can get going. Jump over to things. DIN mount UHP series. Looks. Oh. Would you do something like that? We just have regular over on the boron. Boron DIN rail SSD mount, Legos. What the heck? Why am I having such a hard time finding mounts for things? In covers, in covers. Are they possibly out in the or on GitHub? Either one. STL, Electronics Bay, UHP 350. There we go. That's what I want. Simple. Whoops. Boo, bam, bamboo. I popped one of the mounts off for the board there, the Manta board, and it shot up and hit the ceiling. Kind of crazy. Yeah. No, just bring it up. Sure. Delete. UHP 350. Oh, okay. Base. Okay. Yeah, Boron had it. I'm just not enough coffee yet today. Put it that way. You got your Soval Zero yesterday? Nice. Had to take the bottom off twice and still haven't got anything to print yet. Why'd you have to take the bottom off? Okay, so currently we have no power supply. Tracks. Oh, and you know what? I never took that jumper off, which is probably not a bad thing. Because what we can do while we're waiting for that mount so that we can plug some things in. We'll come back here to our Raspberry Pi power supply. Plug that in there. We'll bring this around and plug it in to our USB-C. So we'll just be running everything from 5 volts because we still have the 5-volt jumper here. Not getting power anywhere else, so we'll hit the button, things will start coming up. Interestingly enough, let me see if the screen works. Screen has backlighting. Ugh. It does not have any type of config on it really at this point. It has, we'll just call it a bare minimum. Okay. So what I did off stream was I flashed the board, and once again I wound up reflashing. I went to the latest version of the CB1 minimal, and then I installed Kaya, and then I was fighting trying to figure out why I couldn't connect to get, you know, like list USB serial device or device serial by ID. And then it dawned on me, I was connected with a data cable back to my computer. So as soon as I ran power this way, so the Manta board, so Clipper's all in here. The Manta board has been flashed for USB to CAN bus bridge, okay? And the EBB42 toolhead board has been flashed with Catapult. I can't do the rest until I do the cable and actually do a CAN bus cable for it, which I haven't done yet. So that's about where we're at right now. If we come over here and we look at printer config, it is blank. I've got the CAN bus UUID in for the board, and that's it. We're basically starting from scratch almost. And I was initially just going to take my previous config and dump it in and start tweaking it. And what I think I want to do is a clean Trident, or yeah, a clean M8B, Manta M8P, the config, and then we'll go from there and we'll start copy pasting over, right? Because I'm going to need all the pins. So what I need to do is go find a firmware. We're in the Voron Trident firmware. There is a Manta M8P file, right? And there's for a 1, a 1.1, and a 2. This is a 2.0 version. So we want to grab, well, not grab like that. Come in here, we'll grab this. Control A. Copy. We'll come back over to our printer. And we're going to do a Control A, Control V to paste. Now you might just say, hey, you just got rid of your MCU. You're right, I did. So we pull up Notepad++, and there's my CAN bus UUID. So for here, we will comment out this. We'll put the CAN bus in, and I think we still need the restart command there. X in motor 1, B motor, Y in motor 2, A motor, E in motor 8, which would be the extruder. We're not using that. It would be a toolhead board, so that just gives us some ideas of some things. This is where now I can bring up my prior config. Well, no, we'll be good here. I think it should be the same way. Yeah, let me bring up the prior config in we did download it, didn't we? I thought we downloaded it. I'm just not seeing it. That's going to suck. Okay, so we Awesome. We're starting from scratch because we completely blew away our config. Yes. Which means I'll have no input shaper, none of that. Okay. So we're starting from scratch. It's gonna be great. Yep. MCU temp, post temp, yep. We have X motor and motor 1. We need to uncomment for the 350 size. Now X, we do not have a in-stop connected. So we're gonna have to change this to sensorless homing. I'm gonna have to remember that. We are running 2209s in UART mode, so that should be good. Y stepper motor, in-stop pin PF3. Let's double check that pin. In-stop pin is PF3. Yes. It is closest to the. Okay, so that in-stop set up correct. And we need to tell it it's a 350. Hey, Chris, how's it going? Yeah, probably not. I will as soon as I tell it to home and I ram it into the gantry. That should be fine too. Z0, motor 3. Yes, that's good. Rotation distance for TR8. Oh, yeah. I think these were TR8s. Well, they're standard. They should be standard stock. Z in-stop pin, that gets changed. All new builds need at least a few skip steps. Exactly. So this is going to have a beacon probe. So we need to change the in-stop to virtual in-stop. And I can't for the life of me remember the command. That's why I'm going past it. So all builds have the same Z max. UART for that stepper, sounds good. Motor 5. Would it be motor 5? Oh, because I know why. So now we're gonna have to change some things because it was looking A, B. So it would look at, would that be the E then? Okay, we'll have to change some things. Okay, so right, or the rear is on motor 4. So now we get to go make corrections. So motor 4, step pen, EB4. How's it going, Chris? Hope you're doing good. We got some stuff in the mail. Correction pen, EB3. Now, common sense would say something. Do a Control Z, change that back. Now, I'm going to take these three things right here. Four things. Oh man. Yeah, who cares? They all need to drop down one. That's why I was like, man, I can do this, but grab these. PB4. Direction is PB3. Yeah, we have to figure out the Frex build soon. I'm becoming a geographic bachelor tomorrow. Table pen, PB6. Okay, so that one's done. Maybe. UART pen. UART pen is the CS pen. PB5. PB5. Miss Wright, no, she didn't kick me out. She's going to DC tomorrow. So this is actually stepper 2. Is now on stepper 5. So change that to motor 5. 5 is PG13, PG12, and PG15. The UART pen, PG14. And this is motor 5. There's the 3 Z's. Now what I need to do is add in basically the X1 and X2. So let me do we're going to do something like this. For X. So this will be X1. And they're opposite. So that one's going to be motor 6. And motor 6 is PG9, PD7. X1. Need 1, 2, 3. We need first steps, station. That's okay. Separate X1. UART pen. 6. PG10. .0. In-stop pen TMC 2209 Idler stepper virtual in. I have never seen the Idler stepper virtual in. Well, we got that there. We'll need that for no. Y is physical in stop, so we're good with Y's physical in. We're basically going to need to take this. Throw it here. This is Y1 on motor 7. Okay, and Y1 on motor 7, PD4, PD3. PD4, PD3, enable pen PD6. And UART this PD5. In-stop pen, TMC, stepper, blah, 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 virtual. Okay. X, UART 1, Y, Y1, Z, Z1, Z2. Extruder is going to be on the EBB board. So I need to add the second MCU. So, bump, bump. This will be MCU EBB42. We'll have some type of CAN bus UUID. You know what? Go, that's not connected at the moment, so we'll have to we'll do that. Hey Kenneth D, how's it going? Yeah, we're gonna need to same thing on the end stop or the blah, 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 blah. Z is going to be a virtual end stop as well. So if that's going to be a probe. The extruder is going to be on the EBB44 or 42. Out, out, pen out. There we go. That EBB42. Why is it not giving me motor pin? Product size. Am I missing the motor pins? Kind of a mute point. I know I'm missing the motor pins. While I'm sitting here though, let me peel. We've got a little bit of Captain tape right on here. You can see it's shiny. We need to peel that off so we can get to the dip switches underneath. Probably been a lot easier to try and peel off before putting a heat sink on here. Almost, come on. So Chris, eventually, probably after Rocky Mountain, I'm going to order the panels, or probably at Rocky Mountain, I'll talk to you about panels for that Nebula or the 350 size. And don't put those away. So we're going to use a two-wire PT1000. So we need 1 and 2 on, 3 off, 4 on. So let me make them all on. Then 3 is supposed to be off, right? Yes. So on our focus, there we go. On our little dip switches right here, 1, 2, and 4 are up, and 3 is pushed down. So you have to do those tiny little dip switches so that you can set up your PT1000 appropriately. Oy. Put that away. And I'm still not seeing any pins for motor wires here. How do they not put the motor wires on the... Because it had all the other pinout wires up here, but nothing for the motor. Well, that's craptastic. I guess we have to go look at... Oops, not that. That's 4 on Trident. BTT EBB. Motor. Oh, here we go. There we go. All right, that was fun. Just watching while doing some gaming. Cool, Kenneth. Yeah, Chris, they are some big chunky ones. I got the frame kit and the assembly kit for the frame, and I will probably go through and put the frame together. And I think what I'm going to do is reprint all of my parts to the latest versions of the parts, and basically do a tear down and complete rebuild of that one. Who knows? Maybe it'll get a Chube as well. Because I mean, it's a big printer. Okay, so enable pin is PD2. So the extruder will be, what is it? EBB, whoops, EBB colon PD2. Okay. Third pin, PD1. Yeah, we'll just do EBB. Enable pin. Oh, wait. That pin the first one? PD0, PD1, and EBB colon PD. 0, dir 1, enable 2. Step, dir, enable. UART PA15. EBB PA15. Well, I did say PA15, yes. Okay. I'm gonna have to figure out the rotation distance and stuff. Microstep 16, sure. It is a 1.8 stepper motor. Yeah. Bondtech extruder motors are 1.8, right, Chris? I think that's right. Nozzle diameter. 1. Filament 7.5. Heater pin. Heater pin. EB13. So question for you, Chris, since you're here. Fans. So I'm putting the Takeoff toolhead on here, and the fans are 3628 4-wire 12-volt fans. Would you consider wiring the fans power in series and running them off of a EBB42 board, or would you consider taking it all the way back to the main board? Thermistor, EA. Thermistor, EA. Min temp, max temp, max power, sure. Yep, we'll work on pitted once we get there. Pressure advance, we'll have to work on that. I'm going to add these in from the get-go just because normally a good place to start. E0 on EBB42. Leave it that way. Yeah, I've got to figure out the gear ratio. This is an FXD extruder, so you'd try to run them in series through the EBB. Okay. What I'll do is I'll probably do like I'll try and do a pigtail to link them together. Yeah, I'll see. E0 on EBB42. Filament switch sensor, we don't have one of those. Bed heater, SSR pin. It has it going to HE1 We're currently connected to bed out. Whoops. So we're currently connected to bed out, which would be PF5. I mean, we could, in all honesty, route it the other way, but we're going to PF5. F5. Peter underscore pen PF5. HB. What thermistor type you have? Standard sensor type. Sensor pin should be PB1 because we put it into the thermistor for the bed. Where am I? PB1 is correct. Adjust max power, blah, blah, blah. Max power 0.6. Sure. Man, we can actually ramp the max power up. We'll put that up at 8 for now. Hey, Free Heathen, welcome on in, sir. How are you today? Hope you are doing well. I'm sorry, I am on the wrong darn screen yet again. So we're sitting here going through our config, and I just keep kind of going back and forth, back and forth, back and forth, because we swapped out our motherboard. We went from a Manta M5P to a Manta M8P. And of course, we completely blew away the, my plan was always to pull the SD card out of one, put the SD card in here, and then make adjustments. Well, I didn't do that. I completely blew it away. So I have none of the old config, and we're starting fresh, which is probably a good thing. Probe. This is where we're going to run. I'm not. Yeah. Let me see. Takeoff. Do we have anything here? Assembly, top plates, SLM, laser, FDM. No, so there's nothing in Takeoff as far as configs. There are some notes. We may lose some XY movement. So an SLM tool head using 36/28 in Chube with no X loss. So nothing left to right. There will be some Y loss, 17 millimeters from hitting the front door unless you have clicky-clack door, a 2.4 that allows moving the bed back, or a 40/40 base frame. Dang, I guess I'm going to lose 17 millimeters. And for Trident, you need to cut the front left and rear lead screws or use these to avoid losing travel. I used those. I might have to get a clicky-clack door for a 350. Okay, so yeah, we're still on our own. We're gonna have to do a lot of updating. So how's it going, Free Heathen? Raid and run? I feel you. All right, sounds good, Waters. I'll let you know tomorrow if I am going to stop by. So cool. The probe stuff, I really wish they had an offset for the probe. It looks like it's Y is direct on, but we're going to be off to the side a bit on X. What I may do is reach out to Modbot and see what he's got. So we'll work on this. This is going to be a beacon probe, by the way. Fan control. And by the way, you see that there's something missing here. I didn't realize that the UHP 200 and the UHP 350, the 350 is a little bit wider, so I'm printing off some new DIN rail mounts. I have to switch from the 200 to a 300. I think the 200 might have been able to support the motors, right? Because we just added 2 more motors with this setup. However, I forgot that I'm putting a 100-watt heater on a Chube in here. So we're going to update to the 350. Print cooling fan. So this would be, yeah, we'll take this into fan 1. Yeah, so the fan closest to the heater will, or yeah, to the hot end heater will be the hot end fan, which is non-existent. So PA 0. So this will be EBB fan 1, which once again we said was my God, this is killing. Okay. PA 0 for fan 1. PA 0. Oops. So EBB colon PA 0 and 1. Fixed start times. Oh, wait. How is that going to work? So we've got, ooh, so if we run the fans off the board, all we have is 2 wires. So what would we do? Run them in series and power them from here? Because these are 4-wire fans. I'll have to think through that a little bit more, I think. Heater fan, hot end fan, this is not used because, well, this doesn't have a hot end fan. That makes that easy. Controller fan. The controller fan are black and red, which is to the first one on the board. So our first fan is fan 0, which is EF7. EF7. Exhaust fan, sure. Fan 2. Whoops. Fan 1. EF9. This is our bento box. So yes, we want this heater bed, heater temp 60, sure. Solar fan when that kicks up. This same thing. The other ones will be unused for the time being. LED control, this is different. We do have an ergaba in here. See if we've got some idle timeout, safe Z home, Z position. Sounds about right. Z tilt, we're using a 350 build, so we will uncomment this. Speed, horizontal move. Sure. Some of this will change once we get to the next piece, which will be playing with the beacon. Display. Our display is not working. It's an SPI display. I will have to look at the stuff to get that going. NeoPixel for the display. Basic macros. We will want to get rid of that and replace with our own macros. Oh, wait. I don't have my macros because we blew them away. Either that or I pulled them down somewhere else. We pull them down over here. Okay, we'll have to figure out all of our macros too. Okay. So we have a screen that we're going to have to figure out. It's a DFT 35 SPI. We'll have to grab that information. DFT 35. Not that. Version 1 or version 2? Version 2.1. What do we need to do? Work with Raspberry Pi. Work with CB1. We need to go into our board env.txt file. Okay, we can do that. Putty. So how's it going, Free Heathen? Actually, you said he was rating and running. So let's see. So this is Pi. And a super secret password. So, Chewy, I think you were the one that was telling me this, that the password would be root, and that is correct. If you use the latest version of the CB1 software, it is root, and during the initial setup, it will force you to, one, put in a new password for root, and then two, create a user, which I created Pi and gave it the normal password that I use for all of my systems. So and if Pez Liz is around, no, she'll like these. This is the little Flexi Kitten by Flexi Factory. My mother has asked me to print 10 or 12 of these in pinks and purples. So I grabbed a bunch of cookie CAD when I was down at Echovate and printed out. I'm printing out like 4 of each color. And this is the Lavender Elixir. But yeah, I'm printing those out, and I got to get those over to my mom so that she can get those handed out. She's handing them out to the kids for graduation. So I need to get into the board ENV text. So where we're at now, we're going to CD into /boot. We'll do an LS. We should see a board env.text. Yes, no, maybe so. Not seeing a board env.text. Maybe it's the armbn env.text. Armbn env.text. And we're going to see some stuff in here. And we're going to change some data. Boot logo true, false. true. Overlay prefix Sun 50IH616. Yep. Default display for debug. Here's the default display for debug right here. Specify HDMI. And then uncomment for the SPI display. That's where we're going to go. So uncomment for SPI screen, which is the overlay TFT 35 SPI. That is uncommented. OS image of 221 version is used. Set the overlay TFT SPI 25 instead. To 5. Control X. Yes to save. Enter to write. Error writing. Dang it. Why? Because we didn't do a pseudo nano. Darn it. Okay. Is that to true? The overlay TFT 35 SPI, we'll go ahead and put 25 in there. Control X. Yes, enter. Okay. Hopefully we don't need to recalibrate touchscreen. We will, however, need to do a reboot for that to save. But before we do that, I don't think we'll have any issues. Software settings. Yeah, so we should be good there. Now I want to go to Beacon GitHub. Oh yeah, those colors are really pretty, Peslin. They're definitely really pretty. So, documentation, sure. Start. Contact, command references, config. We do have a Rev H, by the way. Do not hot plug. Good to know. Mount beacon. It's mounted. It'll keep out. Okay, route cable. Route your USB along the filament path or umbilical and plug it into your single board computer. The included cable is not recommended for routing and cable change. Yep, gotcha. Install beacon module. So we will need to do this. Come on, no. Click here to copy stuff. You have not already installed Numpy for the input shaper tools. It may take 10 minutes depending on the speed of your single board computer. Okay, so they're going to add that, which is going to move us back to our home directory, download the software, and then do the install, which, like they said, is going to take a while because I don't think Numpy was installed by default. Configure Moonraker. Yep, we'll want to do that. So we'll grab this stuff. Come back over here. We're going to save, not save and restart, but just save and close. Moonraker. Come down to the bottom. Add that information. Save. Configure Calico Clipper for Beacon. And the basic configuration to your printer config. Be sure to update the X and Y offset values of beacon relative to your nozzle to avoid missing your bed on first test. Got you. Come back into our printer config. We'll come back down here to probe. This is the standard for an inductive probe. We're going to have beacon instead. Yeah, I think I'm just going to comment this whole thing out. And we'll put in beacon right here. We'll have to get the serial ID once I plug it in, and it says not to hot plug it, so we will not do that. X offset, -20, update with offset. Y looks to be right in line, and 20 might actually be a correct value. We get a smaller ruler here that I can use to check this offset. Nozzle to about the center. I think I'm going to go with 23. I'm going to go with 23. Hey, Hutch Makerspace, how's it going? Hope you're doing well. Set the safe XY position for Z homing, typically the bed center. Safe Z home, XY position, update for your machine. So we'll take a look at that. Our Safe Z home. So safe Z home is home XY position 170, 170. About right for a 350 build. Speed 100, Z hop 10. Their suggestion is Z hop 3. Okay. And I think our speed, we want to go something other than 100 when doing things like contact, but we'll hold off 1 second. Grab this information here for our Z in-stop pin. Z in-stop pin, probe, Z virtual in-stop, use beacon as virtual in-stock, homing retract distance. Move that version. Homing speed is 8. Safe Z home, wasn't it? I was thinking. Safe Z home had a really fast speed on it. I don't know why it would be 100. How are we doing over here? Hey, all done. That's good. Your printer presently has a probe section. We need to remove it. Beacon replaces it. Okay, we did that. Bed mesh config. Beacon requires a valid bed mesh section. Da, da, da. RevH accelerometer. To use the resonance tester, you just need to be pointing to the data source. So need to add this. The resonance is normally all the way up at the top. I'll switch this to 150, 150. That way it's centered. And actually we're 350, 350. It's actually like 175 then, huh? E public math. 175, 175. Safe C home, 175, 170. Here we go. Okay. What else? Calibrate beacon, basic test first. Okay, so we're gonna have to do some type of firmware restart. And before we get going on that, this is cooled down enough. Let's try and get our power supply ready to go back in there. Because we'll have to do some more wiring. Let's put some heat set inserts into this. So what we'll do is, it's about that time, do a save restart. It'll throw all kinds of errors because we don't have an MCU. It doesn't know about EBB, all that good stuff. That's fine. Shut this down. Pull this stuff out of the way. And we'll get a few more things installed. One of which will be our beacon probe, and I'm trying to think how I want to route that. Quite honestly, I believe the beacon probe is going to route around the back side of the printer. So what I'm going to do is I'm actually going to route my words on stream again. I'm going to route my EBB cable around the back side of the printer and come in through the exhaust port. So in order to run the beacon probe, we'll loop that around the same type of direction and come in through the back panel with it. I'm just going to basically make a rather large hole and have to come up with some way of doing, well, a pair of cable glands through the back, one for the beacon and one for the, whatchamacallit, the CAN bus cable. So I need to do a couple of heat set inserts. Let me flip the printer up. We'll actually move the printer off. We'll do the heat sets, and then when we put the printer back up here, we'll set it back upright. I don't know why. All right, I'll have to mount the power supply. Like, that's the thing that I'm trying to do. But we'll mount the power supply, and then we'll get the I'll mount the power supply, get that plugged up, and then we'll work on the tool head some. I guess we can also create a CAN bus cable because we're going to need that. We can't do any testing of the tool head without a CAN bus cable. The good thing is the CAN bus cable I don't have to plug in underneath because we'll have the back piece. You're freezing, almost time to make supper. Why are you freezing? I mean, supper I get, that's hungry. That's not freezing. So Chris, if you're still in here, is the plan for our joint stream just going to be doing the, the Twitch join a stream thing, or are we going to try and do something else? I know, I think it's Modbot and Steve have been doing, they've been doing like Zoom or something, and then just broadcasting Zoom. It's weird. You're thinking so? Okay, that's I don't know I really don't know the best way to do it. So I was kind of half joking when I was telling Joel that he needed to make directions to how to set everything up with his major stream today, because he was having all kinds of technical difficulties. Okay. That's really... Oh. All right. Hot thing goes down here out of the way. I'll grab it later. This goes back in here. I need some M3 by 6s or 8s. Button heads, not the cap heads. Like I said, you can just get these started and then slip them on the side. So, tighten them down. The biggest thing is just making sure that you get them going in the right or in the same direction. Rainy and cold there, gotcha. Gotcha. 1968. It's 80 degrees here in North Carolina. It was a little windy, but it's 80 degrees today. Okay, so this needs to get mounted back underneath. I need to do up the wiring, which would have been great to leave the printer up here to do that. And then I was thinking I was going to have to do some craziness, but I won't. I'll just have to flip it up on its side. We can start playing around with trying to get the rest of the wiring on the tool head done. So, working on that hernia. In the right way. Okay, and this side, they all come out. Red is load, right? Red is low, blue is neutral, green is ground. Yeah, get a good twist in there. I mean, I've only had one meniscus tear, so might as well tear the other one up too, right? Might as well tear the other one up. I mean, I've screwed up both shoulders, so I might as well screw up both knees, right? So Chris, are you planning on streaming tomorrow by any chance? Because if so, we can try and like I'd have to print all the parts for Frax, but we can try and just do a stream and figure out, you know, the technicals. Come on, are you freaking kidding me? Okay, so that's there, that's there. We're gonna bring this over. Okay, that's there. We got our USB for our beacon plugged in. We can go ahead and set this up. Lifting with my back the whole way, because why not? And here is our tool head. The Takeoff tool head. We'll have our beacon probe over here. So this is basically going to come in through the back side, loop down, and plug in right there. We'll have our two fan plugs that will probably come up a little bit and maybe plug in up in this region. I'll have to figure out how to do this. Like I said, these two fans are 4-wire fans. That's where I was thinking it might actually be better to bring these all the way back home run. I'm only going to put the beacon in down here, and I should have some thin-ish zip ties here. There you go, Chewy. Keep talking about rapid. Keep rubbing it in, then it's like right there for you. I think for once, I'm just going to pop out their zip ties and use them as I'm working through here. Okay, so pull this way. Our thermistor wires are going to go onto the tool head board, which I have not mounted on here yet. I was contemplating just using the built-in or the standoffs that came here. However, yeah, these are going to be way too long. This is not a full-size NEMA 17. This is a NEMA Pancake. So these 4 will not work. I did print out a mount here. I'm not sure if this will work either because it's designed to use oh, what am I thinking of? It's typically designed to have the standoffs back here that the LGX comes with. This is a Bondtech motor, not an LGX motor. So what I'm going to do is see, I'm going to pop one of these out, see how deep the screw is, and then we'll try and figure out an appropriate depth screw. Maybe. I think this one will start to round out. Might have to grab the iFixit kit to try and get these out. Yeah, that'll just pop out. iFixit, where did I put you? Not in its right spot. Well, you could always go to the show just to go to the show, but like Phillips had. Yeah, I was going to try and go, but one of my coworkers resigned, and when he resigned, that leaves me without a backup. So, can't kind of go now. That's what you do for sure. But still, it's just too, yeah. Okay, so this is an 18 millimeter screw. Add to that the depth of this part. And I would need probably like a 20. Now I should be able to pop all 4 of these out without this motor going anywhere. Yeah, and it's funny, I saw that that Smurf moved from like December to March, I think it was. So that'll be kind of cool. Okay, so took that off. We got that jumper on. So on our back side here, I took the 5 volt jumper off, and we've got the 120 ohm resistor jumper on right here. So that'll be good. We'll need to mount, or we'll plug in our hot end wires. Yeah, because we'll want to get that done first. So let me clean these up, and we'll put some, I think we're going to do the one trick where we put some heat shrink tubing on it. Strip it down some, and then we'll slide the heat shrink tubing up, and that'll give us a little bit more ability, because these screw down terminals are like super tiny. And I'm going to want to try and put ferrules on these. And I'm going to have to strip these back some. And when I do, I invariably play heck with the fiberglass reinforcement on here. Pull this back some. These. I actually got two decent cuts on those where I didn't have a lot of excess fraying. Bring this up and clamp it or shrink it down. Sorry about that. Okay. Bring this up closer to the end. And once again, the reason sorry. The reason to do that is these are pretty thick wires on these um, heaters, and we're going to need to get the smallest ferrules possible on these in order to be able to get into the tiny openings on these boards. So we really need to get rid of as much insulation and make those wires as small as we possibly can to do this. So that said, got that taken down some. We'll go ahead and grab our ferrule kit and get a couple ferrules on that. And I'm going to start by trying to see which ferrules will fit and go from there. 18 gauge wire. So should require the red ferrules, and will my red ferrules fit in there? Going to be tight. going to be tight. We might have to do a little bit of extra squish. The other thing that I normally wind up having to do on these is because it's such a small connector and it's not as deep, I have to trim the actual ends off the ferrule as well. So we'll come in here, we'll crimp this ferrule. We'll cut them a tad bit shorter because I don't want them sticking out any farther than they have to. No chance of arcing. And then we'll get this wired on first. Then we'll mount the board. Yeah, I am going to have to do some additional squish. So I'm going to start by just taking off the first section of the ferrule crimp. And that doesn't shorten it up much, but it shortens it up maybe 2 millimeters. And that will really help help us get these in there where there's not like a lot of ferrule still sticking out. And then I'm also going to come and crimp these down on both sides just a little bit more. Still trying to keep them square so that we can get them in there. Get that in, but still may need to make it a tad bit smaller, like shorter. Aren't you? Goes in. You can try and they slim the wire down some and put the next smaller size ferrule in, but I try and keep as much as of the wire as I can, especially when we're dealing with a 100-watt heater. You don't want to skimp yourself on the wire diameter here. Come on, you. Why are you being a pickle? I think I do want to make this a tiny, tiny bit shorter. You fighting me? Because I'm on stream, that's why it's fighting me. Like getting it partially in there, about 2/3 of the way, and then it kind of jams itself. You want to be careful that you don't bust this off of the board either, because then you'll be dealing with a different problem. Screw those down. And this is going to wind up coming around like this and going on there. And then it's going to be rubbing on the extrusion the entire time. Not like what I need is 90-degree angles on these. Don't like the way that's working. And of course, one of the other ways to do this is just, I don't know, extend all the wires and take it all the way back as one big umbilical, which is another option, rather than doing it this way. I think that's what Modbot wound up doing on his build, was just doing one large umbilical back. Definitely have plenty of room on my PT1000. Pretty darn close, that's for sure. Let me think what I want to do here. And with that said, it is, what, almost 9 o'clock? We've been going for about 4 hours. So I think what I'm going to do is go ahead and call it quits, guys and gals. Chris, like I said, if you're going to stream tomorrow, I can try and just join your stream, and we can test out audio and stuff like that if you want to give that a shot. But like I said, I'm going to have to print out Frax parts anyhow, so we can't do anything like that just yet. But for now, let me see who we can go raid into. Who's up and running. Science doing a charity stream, Rise of the Podcast. For the day, Thug Shells, you can pull, Maker Deck, Warhamster, mods. Okay. All right, yeah, sure, just ping me. Okay, so we have some options. We could do like Science, we can do Astro Canuck, we can do something like Bamley DJ if you guys want to do music. What do you guys feel like doing today? Bam? Okay, we can do that. We can do that. We can jump over to Family DJ and do some music. Thanks everybody for being here. Please rate on over with us and show some love to Bam Lee. Hang out for a little bit, listen to some good music, and I will see you guys and gals possibly tomorrow night over on KB3D Stream. Tuesday for sure, maybe beforehand because, well, I'm left without adult supervision. And I tend to stream more when I don't have adult supervision. So thanks everybody for being here. Have a great day, and I will see you next time. Bye now. For those of you watching this on YouTube and you like what you see, please feel free to like and subscribe below. Be sure to click that bell to get notifications of future videos. And YouTube's going to be suggesting a video right over here. Take care. Have a great day.